Hi, I'm online physics teacher Robin DeMarco, and today we're going to take a look at a very simple projectile motion problem. So let me quickly share my screen here. There we go. Okay, and what we've got here is a student throwing a rock with an initial horizontal speed of 11.2 meters per second. She determines the time until impact to be 3.00 seconds. Part A, how high is the rock released from? And part B, how far from the base of the cliff will the rock hit the water? Okay, the first thing we should do is identify or label our various pieces. So I'm going to start off by changing pen colors here. And in this direction here, the horizontal direction, we're told that the velocity, okay, why is my pen not working? There we go. Velocity equals 11.2 meters per second. Now, in the horizontal direction, remember that whenever we deal with a projectile motion problem or a motion in two dimensions, the individual dimensions are actually separate. They're independent of each other. So in this case here, what's the acceleration, excuse me? The acceleration is 0. Okay, there is no acceleration in this direction. Okay, we'll change pen colors and we'll use, I guess we'll do green here. Now let's look at, this is going to be for the vertical direction here, so Vy. And what does Vy equal? Well, there is no velocity in the downward direction to begin with. So it's really just 0. Acceleration in the downward direction. Now this time we do have something. This time we're dealing with gravity. It's acceleration due to gravity. So G, which is, as we know, 9.81 meters per second squared. And we're told that it takes a time, 3.00 seconds for that rock to hit the water. Okay, so let's take a look at our problems now. So the first one, how high is the rock released from? Well, I'm going to leave this in green because this is going to be a height problem in the vertical direction. So this is really going to deal with the vertical part. We'll keep everything color coordinated for us. So we can start off with our equation. D equals the initial velocity times time plus 1/2 acceleration time squared. But remember this, 0, that term is going to totally disappear for us. So what that means now is we can take this and this is going to be now written as 1/2 times acceleration, 9.81 meters per second squared, and the time of 3 seconds, and that's going to be squared. And if we run this through the calculator, we're going to come up with an answer of 44.1 meters. So this height here, from the point where the rock is released to the water, is 44.1 meters. Okay? All right. For the second part, I'm going to go back and change my color again. We'll go back to the red just because, again, we used it up here. And for the second part, what we're looking for is how far from the base of the cliff is the rock going to hit the water? Now, in this particular case, again, acceleration is 0. There is no acceleration in the horizontal direction. So what this means is we can do a basic velocity equation where V equals the displacement divided by the time. But I'm looking for the displacement that's involved. So I'm going to rearrange this equation here. My pen is being really touchy today. So we're going to rearrange the equation as the displacement is equal to velocity times time. Okay, so substituting in here, what we get is 11.2 meters per second times our 3 seconds. Again, using your calculators, we'll find this is 33.6 meters. Okay, I hope that helped. If you enjoyed the video, please give me a thumbs up. And if you take a minute, please, and hit the subscribe button down there. And next time I put up a new video, you'll get the notification. Thanks. Have a great day.